Hello, Integrated Math 1. Welcome to lesson 1.1.3 C. That's right, we're on part C. We're on day 3. We're almost there. We're going to make it. So we're on page M1-39, page 39 here. And you know how this goes. We've already done warm-ups number 1 and 2. We're just now going to do number 3. Again, identify the domain and range of the relation described by the set of ordered pairs. And of course, you also need to write an equation using the variables x and y that map the domain to the range. You've done this before for the others. You know domain is x. You know domain is your input. You know that range is y, range is your output. You know this. So go ahead, go for it, hit pause, work this out, hit play to check your work. All right, domain, we said that was x, right? So my x's are -3, -2, -1, 0, 1, and 2. There's my domain. We said our range was y, so fine. Y coordinates it shall be 3, 2, 1, 0, -1, and -2. Now the next trick is to figure out how did my -3 become a +3? How did my +2 become a -2? Well, it looks like we're just doing the opposite, right? Mathematically, how do we usually represent opposites? That's right. We do it with a negative sign. So y equals -x because we know negative just means opposite. That's all it is. So it just means we're finding the opposites of each of these. And the easy way to write that is y equals -x. Magical. So yeah, we're on day 3. We're recognizing functions and function families. We have already been working on all of these with defining our functions, using function notation, looking at different representations, looking for characteristics of functions. But we've now been narrowing it down to function families. And we've actually already found several function families, right? We found linear functions, exponential functions, quadratic functions, linear absolute value functions. We've already been playing this game. But we're now going to keep it going. We have a few more key terms today. Linear piecewise functions, x-intercept and y-intercept. X-intercept and y-intercept probably isn't new to you, but linear piecewise functions, that's a new guy. So you're going to want to open desmos.com/calculator on your Chromebook. Have that window open because you know what we're going to do, right? We're going to graph. We're going to figure this out. So I'd like you to analyze each of the functions shown. I've got 2 of them here. And these are funny looking. I get it, right? Look at this. F of x equals -2 when x is less than 0, but f of x equals 1/2 x minus 2 when x is greater than 0. So it's kind of weird, isn't it? But here's what I'd like you to do. These functions represent the last 2 graphs of functions from the no absolute minimum and no absolute maximum category. Okay, we're like, they don't have a minimum, they don't have a maximum. These are our last 2 graphs. We've got everybody else sorted into families. This is the last one. So you're going to use Desmos graphing technology to determine the shapes of the graphs. Then you're going to match each function to its corresponding graph by writing the function directly on the graph that it represents. So you're going to use Desmos, right? You're going to graph it, and I'll help you with that in just a sec. Don't panic, don't panic. You're going to graph it, and then you're going to figure out which graph this equation goes to, and you're going to write this function directly on your graph once you match them up, all right? Now, if you're freaking out about Desmos, let's talk, shall we? Let's talk. Let me help you set up this one to give you the idea of how this works. So we're going to do f of x equals -2 when x is less than 0, and f of x equals 1/2 x minus 2 when x is greater than 0. And here's how this is going to go. So I'm going to do the first part. F of x equals -2. And we said, oh, it helps if I put in an equal sign, equals -2. And we said for x is less than 0. So here's how you do that on Desmos. You know, there's parentheses, there's brackets. Those are the hard ones. And then there's like the curly brackets. Do you know what I'm talking about? So I'm going to hit the curly bracket button. And if you don't know now, you know, these are the curly brackets. They're on your keyboard right next to your P. So I'm going to put in my curly brackets, and that is where I'm going to put the domain, where I'm like x less than 0. Other curly bracket. And check it out. It gave me the line f of x equals -2, but it only gave me that part of it from when x is less than 0. Which means I can now do the other part of the function, because if you remember, the other part of it said, oh, but f of x equals 1/2 x minus 2. But notice I don't want the whole line. I only want it, again, curly bracket, from when x is greater than or equal to 0. Ooh, now this should match up with one of your graphs. So this is what we're doing. This is how you do your piecewise functions, and it works out pretty cool. It looks cool. Let's just be honest. It looks cool. So I'm going to come back here. Boom, I'm going to come back here. So I would like you to use Desmos to graph these functions and decide which graph goes with which function and write it right on the graph. Go ahead and hit pause to finish this off. Hit play to keep it going. All right, people. All right, people. So you've probably already figured out that this function right here is graph A. No, it's not graph A. Oh, I got it mixed up. Dang it. I got it mixed up. This guy is actually graph P. Sorry I have these mixed up. That's so awkward. So embarrassing. I have these mixed up. This guy is graph P, so you should write this on graph P. Sorry. And you should write this on graph A. Sorry. Hang on. I'm going to fix it. Watch this. I'm going to fix it. I'm going to be like, that's with that one, and that's with that one. Sorry. My bad. My bad. What you have just sorted, you've just sorted the remaining functions into one more function family. The family of linear piecewise functions includes functions that have equation changes for different parts or pieces of the domain. I mean, check it out. This graph here is literally pieces of functions. I want this piece, and we stitched them together. So they're linear piecewise functions. Check this one out. I have pieces of my functions, right? I've got 1, 2, 3 pieces. 1, 2, 3 pieces that we stitch together for given domains. So they're called linear piecewise functions because they literally come in pieces. It's kind of how it works. Yeah. So you have now sorted each of the graphs and equations representing functions into one of 5 function families: linear, exponential, quadratic, linear absolute value, and linear piecewise. Let's focus for just a bit. And don't get me wrong, the others are important, but for now, can we take a moment to focus on just the linear and exponential functions? So you're going to want to pull out those groups from last time, pull out those linear and exponential functions. And we're going to we're going to be playing with those. You'll learn more about quadratic functions, linear absolute value functions, and linear piecewise functions in later math classes. In this course, we're really going to be digging in deep on those linear guys and those exponential ones. That's where we're going to start digging in a bit. So you've got 2 pages here, pages 56 and 57. And you have your linear functions. So on page 56, you can see linear functions. And on page 57, you also should have your exponential functions. So what you're going to do is I want you to glue in your functions. Glue your linear functions to the linear guy, your exponential functions to the exponential guy. And then just give me some descriptions down here. Tell me what you can tell me about the domain and the range, increasing, decreasing, constant. Just tell me what you can tell me here. Maximums or minimums, curves, lines. Tell me about their behavior. Go ahead and hit pause to glue in your graphs and describe all of these lovely guys. Then hit play when you're ready to keep going. All right, I did mine. I did it. Did you want to see mine? So we said the linear function family is that whole f of x equals ax plus b. And we said the graphs that go with this one were, and sorry, my eyes aren't as good as they used to be, f, I think that's I, and r. So or is that an L? That's an L. My bad, can't read. So F, L, and R, you can see I've got one is increasing. I've got one that's decreasing. I've got one that's constant, right? So it can be any one of these, but notice it only does one. It only gets one. My domain and range, all real numbers, baby, forever right, forever left, forever up, forever down, all that good stuff. Unless you're constant, you don't go up or down at all, I guess. Maximum and minimums, well, there's no maximum or minimum. It goes up forever, down forever, up forever, down forever. So no maximum or minimum on my linear functions. And they make lines, straight lines. I mean, this line, some of these lines aren't connected, but they make straight lines, straight lines. For my exponential functions, that was our f of x equals a times b to the x plus c. Those were these guys. So we had G, I, M, right? These are the ones that we decided were our exponential functions. I've got two that are decreasing and one that's increasing. So increasing only or decreasing only. These guys are never constant. There's no such thing as a constant exponential function. If it's a constant, it's not an exponential function. Sorry, true story of that. Again, domain and range, all real numbers, just depending on the situation. No maximums or minimums, right? Because we're going up forever. They are curvy though, right? Our exponentials got curves. Now, don't worry. You don't need to know everything there is to know about these function families right now. As you progress through this course, you will learn more about each function family. So don't freak out if you don't know everything right now. Always good to realize. And there's one last little thing I did want to, two more little things I want to point out. First of all, please recall that the x-intercept is the point where a graph crosses the x-axis. The y-intercept is the point where a graph crosses the y-axis. So please remember that. I have given you so much information over the last few days. Can we sum up real quick? Can we sum up? Because this was a lot of information over the last couple of days. So we're going to sum up a little bit. I'm going to use different colors to help us out as well. So we had different function families, right? We had the linear family. This is a big one. We're going to play a lot with linear functions, these guys around. So the linear function family, these guys made straight lines. Like they went up, they went down, they might be constant, but they make straight lines. And so let's make a few notes here. So we said no max or min, right? No maximum or minimum. Straight lines, we should make a note of that. Straight lines. And on an equation, this is the whole f of x equals ax plus b. You might know it better as y equals mx plus b. So just keep that in mind. You've seen linear functions before. They are not new to you. So if you see something that looks like f of x equals ax plus b or y equals mx plus b, that's a linear function. That's all it is. I'm going to pick out a different color here, though, for some of our other guys. I'm going to pick out another color. I'm going to get a nice green going on here. That is green, right? Yeah, that's green. Then we also had our exponential function family, right? So exponential. These guys were curves, right? They'd swoop down. Ooh, sorry about that. They would swoop down or swoop up. So again, in some ways, they are very similar to our linear functions, right? There's no maximum or minimum, right? They're either going up or going down. There's no changing directions, right? Not really. These guys are curves. These guys curve, right? These are not straight lines. These guys got some curves to them. And these are the ones that look like f of x equals a times b to the x, and we'll just put a plus c. Here's your clue. Here's your clue right here. If you see an x in the exponent, it's an exponential function. That's probably why it's called an exponential function, because there's an x in the exponent. If your independent variable is in the exponent, you're dealing with an exponential function. That's just how it goes. Let's real quick touch on our other function families. Make sure I got my blue on. I do. So we did talk briefly about other function families, right? We had our quadratic guys. You'll play with these a lot in integrated math too. Oh my gosh, you will play with these a lot in integrated math too. So our quadratic functions, those are the ones that were parabolas, right? They opened up or they opened down, okay? That means that quadratics increase and decrease. They do both, right? We go down and then up, or we go up and then down. So quadratics were parabolas. They have a maximum or a minimum. They always have a maximum or a minimum, one or the other. We know our quadratic guys. They are, and in fact, instead of curves, I'm going to say like parabola. Or if you want, you can say curves as well. You can write curves, that's fine. You know your quadratics because those guys come in the form of f of x equals ax squared plus bx plus c. This is your clue. If you're kicking off that function with an x squared, that's a quadratic. That's a parabola. You don't even have to see the picture. If you see this and you see an x squared, you're like, that's a quadratic function. It's going to make a parabola. If you see a b to the x power, some number to the x power, 5 to the x power, I don't know, you know it's an exponential function. And of course, y equals mx plus b, that's going to be linear. But wait, there's more. There's more. I want another color. What about a nice purple? That's a good color. Oh, I know what we have. Linear. Is that purple or black? I can't even tell. That's all right. My screen's a little funky. You guys can see it clearer than I can. So linear absolute value functions. It's the value function family. These guys make V's. So these guys either have V's going up or V's going down. So in some ways, they're similar to quadratics, right? They're very similar because they have a maximum or a minimum, right? They have a topmost point or a bottommost point. They're different though because they're not parabolas. They make that V shape. So these are no longer curves. You can think V shape. You can think straight lines, right? Kind of like our linear guys. So these are straight lines. These guys always come, and I'm going to probably not write this right, but that's okay. These guys always come in the form of an absolute value symbol. Hang on, my pen got a little carried away. Easy fix, easy fix. These always have those absolute value symbols right there. So there you go. So if you see that absolute value, the little like absolute value guys, you know it's an absolute value function family. You know it's going to make a V on the graph. It's going to have a maximum or a minimum. It's going to have one of them. The other thing, the last one, and our last family, the one we talked about today. I don't want to do an orange. Can you see that? No. Good grief. Let's just go black. So the last one, of course, is our linear piecewise functions. So our linear piecewise function family, and these guys are weird. These guys are weird. It's literally pieces of straight lines. Okay? This is literally what it is. Pieces of straight lines. They may or may not have a maximum or minimum. They may or may not have a parabola or curve, but these are the ones that you get this going on and you're like, I don't know, it's going to be like -2 or 1/2 x minus 2 for x is greater than 0. And that's going to be for x is less than or equal to 0. These are the ones where it's more than one equation being shoved into one function because it's literally pieces of your lines. Yeah. All right, guys. As always, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, email me. Come see me during office hours. Come talk to me. I'm here for you. And I'll see you guys later. Bye.